Hello everyone, today's math challenge is about a dealing cards question. There are a certain number of playing cards obtained from a complete pack without jokers, so that means the total number of cards should be no more than 52. If I deal among 3 people, that means I will give them as many cards as possible, but each person must have the same number of cards. In that case, 2 cards remain. If I deal among 4 people, 3 cards remain. If I deal among 5 people, 2 cards remain. So the question is, how many cards are there? This question involves quite a bit of calculations. You can pause this video and spend as much time as you need, and then we come back for the answer. Okay, let's have a look at the answer together. In the first situation, if I deal among 3 people and 2 cards remain, and here I can use this algebraic expression to represent the total number of cards, 3x plus 2, and here x is equal to the number of cards in each person's hands, because the total number of cards cannot exceed 52. And here you can see the x can take the value from 1 to 16, and then the number of cards can be calculated from 5 to 50, with 3 being each increment. And in the second scenario, if I deal among 4 people and 3 cards remain, similarly, I can use this algebraic expression to represent the total number of cards, 4y plus 3, and y is equal to the number of cards in each person's hand. And here, the y can only take the value from 1 to 12. And if you calculate out this number of cards, they should be between 7 to 51, with 4 being each increment. And finally, if I deal among 5 people and 2 cards remain, I can use this expression to represent the total number of cards, 5z plus 2, and z is the number of cards in each person's hand. So the total number can take from 7 to 52, with 5 being each increment. And if we look at the numbers in all 3 groups, we will find the 47 is the only common number. So that means it is the only number which can satisfy all 3 scenarios. So it must be the correct answer for this question. If you really love the algebra and want to use this strategy to solve this question, it is not impossible, but it will still take a bit of time. So here, because the total number of cards is equal to 3x plus 2, 4y plus 3, and 5z plus 2, so they must be equal to each other. And then we just try to dig out as much information as possible from this relationship. So firstly, we can make use of 3x plus 2 is equal to 5z plus 2. So 2 can be simply cancelled out, and 3x is equal to 5z, so that is equal to 0.6x. Okay, so this relationship will be very useful later on. And then we can make use of the relationship 3x plus 2 is equal to 4y plus 3, and we can rearrange this equation by moving 2 from left to the right, and then we just divide both sides by 3 to obtain x. So x is equal to 4y plus 1 divided by 3. In this case, of course, x, y, and z must be integer numbers or the whole numbers. So we just have a look here. So for this expression, we can have a look at what values y can take to make x as an integer. Okay, so firstly, if y is equal to 1, 4y plus 1 is equal to 5, divided by 3 is not whole number. If y is 2, and 4y plus 1 is equal to 9, and 9 divided by 3 is equal to 3, so this is good. However, because z is equal to 0.6x, and if x is equal to 3, z is equal to 0.6x is equal to 1.8. It's not a whole number, so it's not good enough. We have to forget about it. So if y is equal to 3, 4y plus 1 equals 13, it's not divisible by 3. If y is equal to 4, 4y plus 1 is equal to 17, not divisible by 3. And if y is 5, 4y plus 1 is equal to 21. So 21 divided by 3 is equal to 7. But again, z is equal to 0.6x. It's not a whole number. And if y is equal to 6, this is 25. It's not good. And if y is 7, this is 29. It's not good. If y is 8, so 4y plus 1 is equal to 33. And 33 divided by 3 is equal to 11. X is equal to 11. But again, z is not a whole number. so we have to forget about it again. And if y is equal to 9, 4y plus 1 is equal to 37, not good. If y is equal to 10, 4y plus 1 is equal to 41, no good. And if y is equal to 11, 4y plus 1 is equal to 45. 45 divided by 3 is equal to 15. So x is equal to 15, and z is equal to 0.6x. 0.6 times 15 is equal to 9. So now it is very good because we have found the three whole numbers. X is equal to 15, y is equal to 11, and z is equal to 9. So no matter which one of them, you just bring x to this expression, y to this expression, and z to this expression, you will also get the same number 47. So the 47 is the correct answer for this question. Thank you very much.